Hello everyone and welcome back to Teach Astronomy. My name's Victoria, but you can call me Vicky. And I am here again today on a Monday to read some Dreams of Other Worlds. So hope you guys are all doing well. Hi Student McLeod, how you doing? Jim from Charlotte, hope you're doing well. Lynn Jersey, you can't hear me. Really? Can anyone else hear me by chance? Because I think I'm getting sound. Okay, you can? All right. Alive with Passion, hello. Welcome. Yeah, I'm using a new microphone today, so if there are mic issues, let me know. But I got a brand new microphone, is here. My partner got it for me, actually, which is very exciting. It's a Blue Yeti, so hopefully streams will sound better now, which is very exciting. And yeah, so today, like I said, it's Monday. We're going to be reading another chapter of Dreams of Other Worlds. This week, it is going to be about Soho, which is I looked this up last time and forgot. Didn't look it up today. We're going to find out, though. It's the Solar and Heliospheric Observatory, and it was a mission in the 90s. And so we're going to read about that and have a good time. So I guess we will just we'll just jump right into it. Lynn Jersey, you figured out your speaker issue? I'm glad. All right. Soho. Living with a restless star. Imagine you woke up one morning and your planet had been engulfed by the atmosphere of a star. High-energy particles slam into the atmosphere, creating shimmering auroras. Sunspots flicker, each one releasing more energy than the largest atomic bomb. Great loops of hot gas uncoil from the star's surface, extending millions of miles. Each whip-crack of activity causes mayhem on orbiting satellites, frying their circuit boards and wreaking havoc on their guidance systems. Your planet is assailed by high-energy particles traveling at nearly the speed of light. Looking at the star, its emission doesn't change detectably from day to day or year to year, but its invisible short-wavelength radiation fluctuates wildly and unpredictably. Where is this place? It's the Earth, and the star is the Sun. This activity isn't because the Sun has run out of nuclear fuel and has turned into a red giant. Our star is in the dull middle age of its life. But the clean, crisp edge the Sun seems to have in the daytime sky is an illusion. That curved space, that curved surface, the edge of the photosphere, corresponds to a place where the gas of the Sun has thinned out to the point where no photons no longer careen into particles and they can travel freely. From that point, they travel in straight lines without interruption, streaking to the Earth in 8 minutes. Inside the photosphere, which is a slender sheath thinner than the skin on an apple compared to its radius, the Sun is opaque and our view is blocked. We see the boundary layer as having a sharp edge, just like a cloud has a well-defined edge. The edge is an illusion because there's no physical surface or barrier. If you could penetrate the Sun in a spaceship, you'd feel no bump. The material of the Sun extends much further into space than its visible edge. In its physical quantities of temperature, pressure, and density, the Sun varies continuously and smoothly from its fusion core outward. It possesses a surprising multi-million degree corona, the influence of which extends past the Earth's orbit almost to the edge of the solar system. Invisible forms of high-energy radiation and subatomic particles, ultraviolet waves, X-rays, gamma rays, and relativistic cosmic rays, streak towards us and pass us at the speed of light. In a very real sense, we live inside the atmosphere of an active star, with profound and surprising consequences for life on Earth. Oh, and yeah, Student McLeod has the official website for Soho if you guys want to look at this while I continue reading. It's a great little website there. Hold on one second and I will show you. There it is. This is the Soho website from NASA. It feels very 90s compared to some of the current mission websites, which is funny. Oh, its 25th birthday was in December. How nice. That's cool. So, yeah. It's a cool thing. You can look at some of its data here. Some pretty stuff. The sun now, sunspots, things like that. Very cool. Thank you for that. All right. Living with a star. Humans have always been aware that the sun's rays sustain life on Earth. But until the invention of the telescope, the sun was thought to be smooth and pristine. There's some evidence of naked-eye observations of sunspots in China as early as 28 BC, and possibly several centuries earlier. Aristotle's strong supposition that the heavens were perfect meant that sunspots probably went undiscovered in Europe for nearly 2,000 years. Galileo saw sunspots in 1610 and noticed that they rotated with the sun. Jesuit astronomer Christoph Schneider also believed them soon after, and he believed them to be orbiting satellites. Also observed them soon after, and he believed them to be orbiting satellites. But by 1630, I think it's pronounced Scheiner. But by 1630, Scheiner had abandoned his Aristotelian, sorry. But by 1630, Scheiner had abandoned his Aristotelian view and accepted that sunspots rotated at different rates, faster at the equator and slower at the poles. This proved that the sun couldn't be a solid object, but was more probably composed of gas or liquid. Through the 17th century, the number of sunspots declined almost to zero, giving a first hint of the sun's effect on our weather, as a period of low sunspot numbers called the Mandor minimum corresponded to decades when Europe went into a deep freeze, with southern England icebound and people in Holland skating on the frozen canals all summer. It wasn't until the 1840s that Heinrich Schwab discovered that sunspot numbers varied with an 11-year cycle. And there is a figure that I can show you for that as well. So here is a figure that's included in the book. It says, sunspots have been systematically counted since the invention of the telescope. There was an extended Mondar minimum of sunspot numbers soon thereafter, which corresponded to a period of very cold climate in northern Europe. This was an early indication of the possible connection between sun variation and climate. So you can see pretty clearly that this Mondar minimum is extremely low number of sunspots per year, if any, compared to every other regular cycle that we see after that. That's pretty interesting. Oh, and you have an illustration of Soho. Hell yeah, let's see it. Beautiful. I'm sure we'll look at Soho some more once we start talking about the actual mission. But there she is. All right. Around the same time that Galileo was doing his pioneering work with the telescope, William Gilbert recognized that the Earth had a magnetic field similar to the dipole field of magnetized rocks, called lodestones. Over the next several hundred years, scientists explored the Earth's invisible magnetic field and showed that it fluctuated in ways that seemed to depend on the sun. In 1777, Johann Wilcke noticed that auroral rays in the polar regions lay along the field lines of Gilbert's dipole. Then, in 1859, two scientists observed a white light flare on the sun, followed 2 days later by a geomagnetic storm on the Earth. This once-in-a-millennium event caused aurorae all around the world, including places that had never experienced such a phenomenon in human memory, such as the Caribbean. The northern lights were so bright in the North American Rockies that miners ate breakfast, convinced that their day had started. Telegraph systems failed worldwide, and operators reported that they received severe shocks by sparks leaping from the equipment. Coincidences like this were provocative, but they didn't amount to an explanation. In 1896, Norwegian scientist Christian Bikeland In 1896, Norwegian scientist Christian Bikeland devised an elegant experiment where the sun was represented by a cathode and the Earth by a spherical magnetized anode. With both situated in a large vacuum chamber, he watched as the apparatus behaved like a miniature Earth-Sun system, with an electrical discharge like an aurora occurring at high geomagnetic latitudes. Not long afterward, George Ellery Hale built the first instrument to study solar flares in detail on Mount Wilson in California, and he confirmed the 2-day lag between flares and geomagnetic storms on Earth. Hale proved that sunspots were magnetized, the first detection of magnetic fields beyond the Earth. He also showed that the polarity of sunspot pairs is the same within a cycle, but reverses from one sunspot cycle to the next. Many researchers have looked for correlations between sunspots and weather on the Earth. Sunspots are actually cooler than the area around them, because the tight bundle of magnetic field lines that they contain restricts the convection that carries heat up from the solar interior. How, therefore, could a sunspot minimum correspond to colder temperatures on the Earth? In part, it's because the area around a sunspot is brighter than an average patch of the sun's surface. So the sun is brighter when there are more sunspots. But that still leaves a mystery. When scientists developed digital detectors in the 1970s, they found that the full variation of the sun's brightness over a sunspot cycle was only 1 part in 1,000, or 0.1%, not nearly big enough to explain significant temperature variations on the Earth. The Maurunder minimum aside, there's no convincing evidence that the sunspot cycle drives non-seasonal climate change, especially the rise in global temperatures over the past half-century. However, the variations of the sun in invisible forms of high-energy radiation are much more extreme than its variation in visible light. Moreover, space isn't the simple and absolute vacuum that most scientists once imagined. 50 years ago, it was shown that the sun is surrounded by a vast region of plasma, a diffuse magnetized gas so hot that the particles are traveling near light speed. The stream of particles emerging from the sun, the solar wind, travels millions of miles to us, where it hits and distorts the Earth's magnetic field. Even though the nature of the effects is complex and subtle, the sun and Earth are one connected system. And I have a picture of a sunspot to show you guys. Here it is. So here's a sunspot. You guys have probably seen... Oh, okay, well, just zoom out, I guess. You guys have probably seen a sunspot before, but here is a close-up one. So it says, the cells and granulations seen in this image of the surface of the sun reflect seething, turbulent motions of high-temperature plasma. Sunspots occur in pairs and are slightly cooler areas where the photosphere is threatened by an organized magnetic field and high-energy particles, and energy can escape. This one is about the size of the Earth. It's an interesting picture. I'll be honest, I really don't like the way that sunspots look. It spooks me a little bit. I don't know what it is. They look very fuzzy, and I don't like it. But it's cool, I guess. But yeah, that's the size of the Earth, so for perspective, I'm gonna change the image now because I don't want to look at that on my other screen. But sunspots are cool. I just don't want to stare at them really close. All right. The weather out there. On a typical summer's day in 2011, the current conditions at spaceweather.com read, quote, solar wind speed 515.9 kilometers per second, 0.3 protons per cubic centimeter, end quote. That's a speed of 1,125,000 miles per hour, and just one atom in the volume of a sugar cube, or a vacuum in a billion times thinner than the air we breathe. The website also predicts X-ray solar flare, 24-hour max, B4. That's a puny flare, thousands of times weaker than the 1859 event. In space weather rankings, B-class solar flares are completely below the radar and negligible. C-class X-ray solar flares are small and have very little impact on Earth. M-class flares cause momentary radio blackouts and can affect Earth's Arctic and Antarctic regions. And X-class flares are major events causing planet-wide blackouts and week-long radiation storms. NOAA, the National Oceanic and Atmospheric Administration, more commonly known as the National Weather Service, provides detailed space weather reports updated every 10 minutes. But what, one might ask, is the relevance of solar flares for our protected oasis of life on Earth, 93 million miles from the sun? Like a lonely sentinel stationed roughly 1 million miles from Earth at the Lagrangian point L1, NASA's Solar and Heliospheric Observatory, SOHO, keeps a steady finger on the sun's pulse. Its game is called helioseismology, or the study of the hum of the sound waves reverberating throughout the sun. Scientists use these acoustic probes to better understand its interior structure and energy production, as well as possibly predict disturbances at the surface, like sunspots. SOHO has demonstrated with great clarity that solar flares, the sudden explosions of matter, electromagnetic radiation, and high-energy particles from the sun, can be unimaginably energetic cataclysms. As University of Michigan space physics professor Mark Moldwin notes, quote, Flares release tremendous amounts of energy in a few minutes and can reach temperatures of 100 million Kelvin, much hotter than even the core of the sun. End quote. Space telescopes like SOHO and the new Solar Dynamics Observatory, SDO, are giving scientists a front-row seat in observing the powerful dynamo of our star. The sun has magnetic poles. Approximately every 11 years, the direction of the poles reverses. Imagine an object trillions of times bigger than a bar magnet, completely reorienting its magnetic field. Such large-scale restructuring unleashes incredible magnetic forces, which lead over a few years to an exponentially greater degree of solar activity and solar storms. The tremendous energetic output at the most volatile stages of the process is known as the solar maximum. John Wiley's IMAX film, Solar Max, has captivated audiences at planetaria and science museums with SOHO footage of the sun's violent storms leading up to the solar maximum of 2000 and 2001. The film's amazing time-lapse footage demonstrates our sun's variability and the explosive energy of coronal mass ejections, plasma and magnetic fields blown off from the sun's corona that can cause severe magnetic storms on Earth. Sorry, I just got distracted by chat. They bother me because it looks like Sauron's eye. Who is Sauron? That sounds familiar, but I don't actually. Who is Sauron? Lord of the Rings character. I got you. The one to rule them all. The one wiki to rule them all. Says, it's Sauron. Gotcha. Okay. It does look like an eye, though. It's spooky. I don't like it. You think of it as a blurry sunflower. Oh, that's excellent. I love the Student McLeod sent this. I guess this is Sauron's eye. So, yeah. I mean... You're very right. All right. The Earth's magnetosphere largely protects us from the solar wind, the sun's outpouring of highly charged particles. More than that, this protection has been essential for the survival of life as we know it. Mars has a much weaker magnetic field and long ago lost most of its atmosphere and all of its oceans, in large part due to the solar wind. However, when they reach dangerous levels, storms in space can cause power grid blackouts, leaving millions without electricity. It may produce a rapid buildup of powerful electrical charges on satellites that can fry their delicate instruments. It has only been in the last few decades that we've realized the impact of space weather. Space weather researchers highlight, quote, I don't know if you guys can hear that, but it sounds... Sorry. Someone's like sweeping or raking outside. And I don't know how many times I have to say this, but there's no grass outside, so I don't know what they're raking. It's just an alley. It just sounds very spooky, and also I can't see them, which is weird. It just distracted me. Apologies. I will continue. Where were we at? My audio sounds great. Oh, good. The mic is very good. It's like I hear you and nothing else. So I'm glad. Where was I? I just got so distracted. We're gonna start right there. I might have read a couple of these sentences already. Mars has a much weaker magnetic field and long ago lost most of its atmosphere and all of its oceans, in large part due to the solar wind. However, when they reach dangerous levels, storms in space can cause power grid blackouts, leaving millions without electricity, and may produce a rapid buildup of powerful electrical charges on satellites that can fry their delicate instruments. It has only been in the last few decades that we've realized the impact of space weather. Space weather researchers highlight, quote, evidence of the influence of solar activity on the terrestrial climate, end quote. Mark Moldwin points out that in the 350-year span between 8900 and 1250, during an extended warming period produced by increased solar activity, the North Atlantic experienced much milder temperatures. This prompted Nordic people to establish communities in Greenland and assign the region a, quote, name that seems peculiar now since it is covered by one of the world's largest ice sheets year-round, end quote. When solar activity subsequently decreased, Greenland froze over and settlers there either migrated or died. Later, during what is often called the Little Ice Age, lasting roughly between 1550 and 1750, historians report, quote, winters were so cold, the principal rivers in mid-latitude Europe froze over, end quote. This has been attributed to a solar minimum and apparently an extended period in which there were few sunspots. The Earth naturally has gone through cycles of ice ages, but as Moldwin explains, the most recent, the quaternary, I guess, extended from 2.5 million years ago to about 10,000 years ago, when large reaches of ice receded. The problem we're currently facing is global warming, where temperatures consistent for the last 10,000 years are now on the rise. Moldwin writes, quote, model predictions indicate that Earth's climate will be drastically different than it is today in less than 100 years because of the burning of hydrocarbon fuel for transportation and energy. That is very quick compared to the normal timescale of climate change, end quote. Added to this is the fact that solar storms can seriously damage the Earth's ozone layer, which protects all life on Earth from damaging ultraviolet rays and could, in turn, further contribute to warming Earth's atmosphere. NASA created its Living with a Star program in 2001 to gather better data for understanding the effects of the sun on the Earth. If we ever move beyond our planet and engage in routine space exploration, we must leave the protective bubble provided by Earth's magnetic field and atmosphere. Our spaceships and astronauts will have to deal with the sun and its stormy weather directly. A small armada of spacecraft has been involved in this effort, but the most notable is a very sturdy device that's still going strong 17 years after its launch. That's the end of that section. You wonder how many astronomy classes meteorologists have to take in their undergrad program? That's an interesting question. I don't think the U of A had a meteorology program, but they might have. But it would be interesting. I'm sure a couple. I mean, yeah, a lot of it's like earth science and astronomy kind of, they decide, the way that like lunar and planetary sciences go along with astronomy. So does like earth science, I like the sunflower picture. Thank you, Student McLeod. Very pretty. We have this, or we have this, or we have a sunspot. Which one do you want? Which one do you want to look at? All right. Let's start talking about Soho. Did I just rip my book? No, I didn't. Okay. It made a noise and it sounded like it ripped and I was scared. Okay. Soho and its Eyrie. On December 2nd, 1995, the Solar and Heliospheric Observatory spacecraft was launched on board an Atlas rocket from Cape Canaveral in Florida. It's the size of a minivan, or, with its solar panels extended, about the size of a school bus, and it weighs roughly 2 tons. Soho was conceived by the European Space Agency, 14 countries and more than 300 engineers were involved in its design and construction. NASA was responsible for the launch and ground operations. It's a testament to the power of collaboration that so many nationalities can work together to produce a state-of-the-art scientific experiment. SOHO is like a Swiss Army knife, reminiscent of Cassini in its size and complexity. Its available space is crammed with 12 instruments that can measure everything from magnetic fields to X-rays. 9 instruments are led by European scientists, and 3 are led by scientists from the United States. But all of them have teams that are a patchwork quilt of nationalities. Unnoticed by the fractious world of politics and tribalism, science is one field of endeavor where national distinctions and borders are almost meaningless. Some of the instruments have intimidating names, like the Comprehensive Superthermal and Energetic Particle Analyzer, built by the University of Kiel in Germany. But generally, they all measure the location, intensity, and spectrum of either high-energy X-ray and ultraviolet radiation or cosmic rays. Multinational harmony does not, however, extend to gender parity. Space astronomy is still male-dominated. All 12 instrument principal investigators and 80% of the science team members are male. Boo. Get some ladies in there. SOHO moves around the sun in step with the Earth by slowly rotating around a point in space called the first Lagrangian point, L1, where the sum of the sun and Earth's gravity combine to keep the satellite locked onto the sun-Earth line. This position is about 1 million miles away from the Earth in the direction of the sun, about 4 times the distance to the moon. SOHO's Eyrie gives it a ringside seat for watching solar activity. Other space missions are using or plan to use L1, but it's perfect for solar observation since the spacecraft in this orbit is never shadowed by the Earth or the moon. SOHO has been beaming data to the Earth from 12 scientific instruments at a gigabyte or 2 CDs worth per day. Analysis of this data has yielded some exciting insights into the sun, including the first images of a star's convection zone, where energy is carried from the fusion core to regions near the surface, and the structure of sunspots just below the photosphere. SOHO has also provided the best measurements to date of the temperature, rotation, and gas flow patterns within the sun, and it has revealed new types of solar activity, such as waves in the corona and tornadoes on the surface. As of late 2015, SOHO data has been used to discover over 3,000 comets. The spacecraft had a nominal lifetime of 2 years. In 1997, it was extended for 5 years due to its great success. In 2002, it got another 5-year extension, and it has since been extended twice more, to the end of 2016. SOHO is now well into its second solar cycle of observations. However, it was not always smooth sailing. That's the end of that section. Oh, and you have a picture of the L1 point. Amazing. Or a diagram. It's not really a photo. You can't really take a photograph of a... Yeah. But this is the L1 point right there. So Lagrange points essentially are places where, like it said, like the gravity between 2 points, in this case the sun and the Earth, combine to keep a satellite locked in place. So it means that, like, if you put something at a Lagrange point, I still don't know how you're technically supposed to say it, but if you put something there, then you're gonna essentially need like no fuel to keep it there. So they put SOHO there, and they left it there, and it'll stay there because of the way the gravity equalizes itself out, sort of thing. And it can just observe the sun, and all of its fuel can be put towards making the instruments work, which gives it a lot longer life. The ideal point, yeah, exactly, because you don't have to worry about it falling back down to Earth or falling into the sun or something like that. So, all right, spinning out of control. It's a space scientist or engineer's worst nightmare. Your mission is working flawlessly, and then, due to oversight or unforeseen events, it starts tumbling out of control. Several $100 million worth of hardware turns a blind eye to the scientific mission. deaf to telemetry and far beyond the reach of astronauts, it languishes uselessly in deep space. On a June evening in 1998, mission controllers at NASA Goddard Space Center in Maryland took note as SOHO put itself into emergency sun reacquisition mode. This mode is a safe holding pattern, autonomously entered by the spacecraft anytime it encounters anomalies. From this point, the ground controller sends a special sequence of commands to recover normal science operation, the first step of which involves pointing the spacecraft at the sun so it knows where it is. Since SOHO had entered this mode 5 times since its December 1995 launch, the controllers weren't too worried. But this time was different. Over the next few hours, a series of mistakes seemed to doom the spacecraft, first causing loss of attitude control, followed by an interruption in crucial telemetry, then loss of power, and finally, loss of all thermal control. It was a bleak day, and it appeared to be the death knell for the young mission. In the control room, the tension grew in waves. At the first entry into emergency sun reacquisition mode, engineers calmly issued the commands to point SOHO at the sun by carefully orchestrating its 3-roll gyroscopes. Project scientist Bernard Fleck said there was no undue concern. Even when a second ESR was triggered a few hours later, there was no panic. Engineers had seen this before too. But as the roll thrusters were firing to point SOHO at the sun, a third ESR was encountered. Out in deep space, 1 million miles from Maryland, SOHO was spinning faster and faster. Then the communication link went down, presumably disrupted by the spacecraft's wild motion. SOHO was unreachable. The subsequent investigation showed that the spacecraft performed as designed. All the errors were human. In hindsight, Fleck thinks they gained a false sense of security after 2.5 years of operations. Like pilots who had done many takeoffs and landings and who had flown on sunny days and through thunderstorms, they thought they had seen it all. They didn't realize that they were in a nosedive. With the spacecraft seemingly lost, NASA and ESA quickly convened a review board to issue a diagnosis and postmortem. The review board concluded that seat-of-the-pants decision-making in the control room exacerbated the problem. Controllers erroneously removed the functionality of SOHO's normal safe mode and misdiagnosed the state of two of the 3 gyros. At any time during the mishap, if they had verified that gyro A was not controlling the roll angle properly, they could have avoided the serious problem. The mundane and somewhat sheepish conclusion: when a very complex system is made and operated by human beings, sooner or later, they're going to do something wrong. Ground controllers kept trying to send messages to SOHO, using the deep space network, but they had heavy hearts. The spacecraft was in an uncontrolled spin, possibly at a rate that could cause structural damage. Engineers believed it was spinning with its solar panels edge-on to the sun, and so not generating any power. As a result, the batteries and the onboard fuel would have frozen into a state from which they could not be recovered. But there was a window of opportunity that admitted a sliver of hope. SOHO's steadily changing orbit with respect to the sun was increasing the illumination on the solar panels for a few months, and they would give the batteries a chance to recharge. 12 hours a day, controllers pinged SOHO in the hopes of getting a response. Then, a month after contact with the spacecraft had been lost, a break. The huge 305-meter radio dish at Arecibo was able to bounce radar off SOHO, and the reflection? It says reflection here, but I think they mean reflection because I don't think reflection's a word. But the reflection was picked up by the Deep Space Network dish at Goldstone. SOHO was spinning at a modest rate of 1 revolution per minute. Communicating with the frozen spacecraft was not easy, but 6 weeks after contact had been lost, a feeble signal was received. SOHO was alive. Over the next 2 months, engineers clawed SOHO back from the brink. They thawed out its batteries and fuel lines and were gratified that none of the scientific instruments seemed worse for wear after having been subjected to temperature variations from positive 100 degrees Celsius to negative 120 degrees Celsius. Some of the instruments even improved their performance after experiencing this bracing range of temperatures. SOHO was back, but 2 of the 3 gyros were not responsive due to the series of mishaps. As luck would have it, the 3rd gyro failed a few months later. Although the gyroscopes were not needed to gather science data, maintaining a sun-oriented attitude used valuable fuel and lowered the margins of safety if anything else should go wrong. Undaunted, the engineers made lemonade with their lemons. They developed special software to enable the spacecraft to point using the control reaction wheels, the first time an ESA spacecraft had ever been operated without gyroscopes. For all the detailed planning, SOHO ended up living by its wits in a series of knife-edge decisions. Oh, and you said web search reveals L1 is about 932,000 miles or 1.5 million kilometers from Earth in the direction of the sun. Very cool. I'm sure there's a very complicated physics formula that you could do, an equation to figure out Lagrange points. But I sure don't know it. So thank you for that, Student McLeod. That's cool. All right. We should ask Michael about the math. We could. Yeah, I'll have to, we got to remember to ask him that on Wednesday, because I'm sure we'll get some sort of eye roll and then a well, yes, but they taught me wrong in freshman year, but this is how you actually do it, but it's really complicated. Maybe I'll make him write it out for us. Do the math. Tell me if there's one object that weighs this much and one object that weighs this much. Yeah, I'll let him know. It was a very dramatic section of the book. Yes. Chris likes to get dramatic sometimes. It's a fun time. Let's see. Mathematical details. There it is. I'm still gonna make him do it. But Astro Kiriani found the Wikipedia about Lagrange points, and these this isn't specifically Earth, right? Oh no, this is figuring out the multiple Lagrange points of any two objects, I think. And so this is the equation stuff, but we'll quiz Michael. Oh, I like Bossa Nova. Thank you so much for resubscribing. Thank you so much. This is your 3rd month with us. Thank you, Charlie. I don't know why, That was weird. Our little thingy didn't come up. I did just update Streamlabs, so there is a chance that our notifications aren't working. But thank you so much. Glad you're here and hanging out and having a good time. All right. Let us continue. Harmonies of the sphere. The Greek mathematician Pythagoras imagined a universe described by numbers. When he talked about the harmonies of the spheres, he meant music that enlightened individuals might hear resulting from the translucent shells that carried the celestial objects. Kepler continued this line of thought and applied it to the elliptical orbits of the planets. These ideas sound archaic, but they're not misguided. The universe contains many periodic and oscillatory phenomena, and the formalism to understand them involves studying the resulting harmonic frequencies. Situations as different as planet, moon, and ring systems, and their orbits and interactions, the spiral arms of the Milky Way, and their interactions between matter and radiation in the early universe are well described in terms of coupled frequencies and harmonics. We've seen beautiful examples of this in the complex gravitational dance of Saturn's rings and moons, discussed in the Cassini chapter. 100 years ago, nobody imagined that the sun could be studied in terms of harmonics. Apart from the sunspot blemishes, the surface seems smooth and featureless. Solar properties vary smoothly through the region we see as the surface. The edge marks the distance out from the center at which the density of gas reduces to the point where light no longer interacts with particles and travels freely. Inside this region, which is called the photosphere, light is trapped, and so the sun's interior is hidden from view. The first inkling that the interior was pulsating came when George Ellery Hale built his heliostat on Mount Wilson in the early 20th century. High magnification photographs showed a surface modeled with fine structure, and time sequences revealed that the sun's surface was a seething sea on which the pairs of sunspots floated like large lily pads. The field of helioseismology matured as the century progressed, and solar scientists identified thousands of different oscillatory modes, The sun rings like a bell. The sun is also like an echo chamber. Sound travels through the plasma and sets up standing waves, like the vibrations of the head of a drum or the air inside an organ or woodwind instrument. Just as seismologists can infer the internal structure of the Earth from the way sound waves and earthquake tremors pass through the planet, helioseismologists can study the sun by seeing how interior sound waves manifest at the surface. This work has led to measurements of the density, temperature, and chemical abundance of the interior, as well as inference of the age of the solar system and the constancy of the gravitational constant. The workhorse instrument on SOHO is the Michelson Doppler imager, since it shows the oscillations of the entire sun. This instrument discovered a layer about a third of the way to the sun's center, where the orderly interior, within which energy flows radially, transitions to the turbulent outer region, where energy moves in convective loops. This is the place where the solar magnetic field is created. Just as large-scale flows like the Gulf Stream and the jet stream are important for Earth's climate, SOHO data have shown that such flows are important for solar weather. SOHO's data is of such high quality that 3D maps of the sun were derived for the first time. The maps answered questions that puzzled Galileo. How deep do sunspots extend, and how can they survive for weeks at a time? The answers? They are fairly shallow, but they are rooted in places where the plasma converges and strongly flows downward. SOHO scientists have managed the amazing trick of holographically reconstructing features on the far side of the sun. All these images are available daily on the web. In fact, a plethora of solar data is available online, since a small armada of satellites is monitoring our life-giving star at all times. Let's find out if a GIF works in Twitch. I think it will. Yeah, there it is. That's cool. Yeah, so with this you can see that the Lagrange points move as the smaller object rotates around the bigger object. And I imagine Lagrange, I'm pretty sure it would work the same way if it was two objects orbiting each other, like binary stars. I'm sure a binary star system, there's a way to figure out Lagrange points between two objects, even if even if both of them are moving and one's not, like, relatively stationary. But cool stuff. Gotta love GIFs. GIFs. How do you guys say it? Do you say it like GIF, like with a like a gift, or do you say it like Jif, like the peanut butter, like Jiffy? I don't know if people care about this anymore. I know it was a hot topic back forever ago. Oh, what is this? This is WMAP Astrocuriosity. Astrocuriosity sent another GIF of, oh yeah, there it is. An example of a spacecraft at Sun-Earth. I don't actually know what this is. It has to do with Lagrange points. Let me restart the GIF. I guess it won't fully restart, but it started here and it made loops and then went down here. I can't say I know exactly what this is. It says an example of a spacecraft at Sun-Earth L2, WMAP. I guess it's just saying the distance away from Earth. And it just keeps going in the... I'm not totally sure, but it looks cool. It's on the Wikipedia page that I showed you guys before. It's right here. So I'm sure you can learn more about it if you go there. I just... I don't want to be reading the Wikipedia page while I'm trying to read to you. So, you were in a debate about the GIF pronunciation this weekend? Yeah, I don't know. I literally just always say like GIF at the same time because I don't want to deal with it. I'm just like, whatever you want to call it, I'll call it whatever you want. Oh, it's an example of the Wilkinson microwave spacecraft performing the Lagrange point. Okay, got you. That's kind of what I thought it was. Nice. A satellite can orbit a Lagrange point. Yes, it can. I don't know how or why, but yes, we should ask Michael about that because I think he would know about that kind of stuff. Hi Parzival, how you doing? We miss you. It's been a minute. Welcome back to stream. We're reading about Soho. All right. Speaking of which, let's keep on going. The rowdy and quiet sun. People have become familiar with the fact that climate change not only involves global warming, but also greater extremes in weather. Rare but damaging events like tornadoes and hurricanes and floods appear to be increasing. Another type of weather that can impact human affairs is space weather. In addition to emitting a continuous stream of super hot hydrogen and helium called the solar wind, I'm gonna move the mic a little bit. The sun periodically ejects billions of tons of plasma in a cataclysm called a coronal mass ejection. Researchers think this happens when magnetic fields are stretched and then snap into a different arrangement, like rubber bands pulled to the breaking point. The ejections are huge clouds of material, as much as 10 billion tons of hot gas, and when they head towards us, they can cause fierce magnetic storms in the upper atmosphere. This extreme weather in space can impact the functioning and the reliability of technology on the ground and in low Earth orbit. Strong electromagnetic fields resulting from space weather induce surging currents in electrical wires, disrupt power transmission lines, cause widespread blackouts, and affect the infrastructure that forms the backbone of the internet. Power grids are particularly vulnerable to electrical overloads caused by space storms. Extremes of space weather also dislocate the radiation belts and damage the satellites used for essential functions like telecommunications, weather forecasting, and GPS, or global positioning systems. Throughout history, people at high latitudes have experienced the Sun-Earth interaction through auroras, but the effect is not always benign. We've already seen that in the dog days of summer in 1859, telegraph wires in the United States and Europe spontaneously shorted out and caused numerous fires. Soon after, the Northern Lights, or Aurora Borealis, were observed as far south as Rome and Hawaii. This was a perfect storm in space, where several changes conspired to produce a mammoth solar flare. The 1859 solar storm was the strongest ever recorded, and it occurred when electrical technology was in its infancy. A weaker storm in 1921 induced ground currents strong enough to shut down the New York City subway system. Much weaker storms in 1989 and 1994 knocked out communication satellites and parts of the North American power grid. Y'all are chatting a lot. What's going on? Oh, we can ask Doc at next show. Yeah, if Michael doesn't have a good enough answer, we can definitely ask Professor Impey. People are just chit-chatting, saying hello. You missed so many things. Especially the book streams. Yeah, I'm sure you were busy. Was it finals time for you or midterms time? I know it was midterms time for a lot of people at University of Arizona. So people were busy. Oh, an active galactic solar winds video. There you go. Look at that. Blowing in the solar wind. I forgot I did that. I was like, what are you talking about? What is that? I was in that video. It was great. It was fun. I think I filmed it too. Yeah. It was a good time. You guys should watch that. We have like two really, 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 really nerdy music videos, science music videos on the Active Galactic website. One of them is about solar wind. Blowing in the solar wind, actually. It's pretty funny. Anyway, where were we? We read that. Okay. Arthur C. Clarke's visionary proposal in 1945 in a letter to the editor of Wireless World to place communication and television satellites in geostationary orbit helped launch the information age. As of October 2009, the U.S. satellite database listed over 13,000 operating satellites in Earth orbit. In 2001, it was estimated that the satellite fleet in Earth orbit was worth $100 billion US. During a single solar storm, billions of dollars of this orbiting hardware can be destroyed, destabilized, or destroyed. After the 1989 storm, Steen Odenwald reported that, quote, satellites in polar orbits actually tumbled out of control for hours, as others attempted to flip upside down, end quote. John Freeman explains why solar storms can decimate satellites despite their sophisticated electronics. Quote, storms in space produce miniature lighting storms on the surface of the satellite and immerse the satellites in a cloud of hot electrons that mimic commands from ground operators, but are in fact phantom commands. If the cost of a fleet of satellites seems detached from our everyday existence, consider days or weeks without internet access or GPS for vehicles, or communication and navigation systems for airline and ocean liner transport, cargo shipping, and road transport. Well, we already know what a week is with limited cargo shipping. Everybody hear about the boat? I typed in, this is so off topic, I typed in the boat into Google today to find out what was up. I did get articles about the exact boat that I needed to know about, and I thought that was very funny. Anyway, we're going to get back to the book now. Solar storms can even affect oil pipelines, which undergo accelerated corrosion from the bombardment of charged particles streaming from the sun, eventually causing breaches in the pipeline. Space weather prediction remains an emerging science spearheaded by NASA, ESA, and the United Nations Office of Outer Space Affairs. Data from SOHO and increasing concern over the impact of space weather caused NASA to commission a new study in 2009. The resulting report provides clear economic data to quantify the risk to the near-Earth environment from episodes of intense solar activity. Extreme space weather is in a category with other natural hazards that are rare but have far-reaching consequences, like major earthquakes and tsunamis. It's likely that more than once in the next 20 years there will be an electrojet disturbance that disrupts the national power grid. In the 1989 event, the loss of some portions of the grid put stress on others and led to a cascade effect. The end result was power outages affecting more than 130 million people and covering half the country. SOHO cannot prevent these natural disasters, but it can give 2 or 3 days' notice of Earth-directed disturbances. And as we become more accurate in anticipating space storms, operators can place satellites in protective modes, shut down or limit power grids, redirect commercial flights, warn oceanic crews and cargo ships, and place astronauts working on the International Space Station in the safest possible location on the station. Such steps will not only save lives, but also protect the information systems that sustain our electronically fragile and networked global community. Oh, I'm just reading chat for a second. You guys had exams. Yeah. I hope they went well. I know a lot of people were stressing over exams the last couple weeks, but fingers crossed they went well. These are the same headphones. I don't know if they look different. I did get a new microphone though. I was talking about that. This is the first day I get to use a new microphone. It's very exciting. It's a Blue Yeti. It's beautiful and I love it. And now you're online again due to increasing COVID cases. Oh, that sucks. Well, hopefully you guys are going to get vaccines soon. I haven't gotten an appointment yet, but I am now in the eligible group to get a vaccine in my area, which is very exciting. So it's just that there are very few appointments available. So fingers crossed I will be able to get one soon, and everyone else will be able to get one as well. I hope you guys have gotten yours if you've been able to. Everybody should get the vaccine. We are a vaccine positive channel here. Let me know if you got yours already. It's exciting. All right. Although Soho's bread and butter is looking for the high energy radiation that's a hallmark of solar activity, there was a recent concern that the sun is becoming too inactive. Through 2008 and 2009, there were fewer and fewer sunspots. In part, this was due to the natural solar cycle, but the calm was eerie. Entire months would go by without a single blemish on the sun, and its solar minimum was as deep as it had been in a century. Bill Livingston and Matt Penn of the National Solar Observatory made the unsettling discovery that the magnetism of sunspots is declining by about 50 Gauss per year. Since sunspots have no substance, they're just dim, cool markers of a concentration of magnetism, the worry is that the magnetic field would drop below 1500 Gauss, at which point no sunspots can form at all. Did decline like this presage a return to the Mander minimum of the late 17th century, when the European climate chilled markedly? Luckily, in 2010, normality asserted itself and the sunspot number started gradually rising. The sun is also fairly quiet in terms of the variation of its energy output. From peak to trough, the variation in total solar flux is only 0.1%, and no long-term variation has been seen over 30 years. The extreme ultraviolet tail of the dog wags much more. What? The extreme ultraviolet tail of the dog wags much more. Sorry, I was just... It's a delightful little turn of phrase. Anyway, 30% within a few weeks and a factor of 2 up to 100 over the whole solar cycle, depending on wavelength. This has important implications for our understanding of the Earth's climate, since human-induced change must be distinguished from natural variations in solar output. Perhaps one reason the sun is so equable is the fact that equable. Perhaps one reason that the sun is so equable is the fact that it steadily snacks on comets. One of the surprises of the SOHO mission has been its prowess as a comet hunter. The trawl is already well over 2,000. The large angle and spectrometric coronagraph blocks the sun's face with an occulting disk, creating an artificial eclipse. Most of the comets are sun grazers that fly like Icarus very close to the sun and then grow tails as their icy cores are heated. Tony Scarmato, a high school teacher from Calabria in Italy, discovered the 1,000th comet in 2006, and 2/3 of them have been found by scouring coronagraph data just after it's taken and put on the web. SOHO found its 3,000th comet in mid-2015, and it has discovered most of the comets for which orbits have been measured since 61. That's 20 years. The dance of fire and ice has become a way that the public has embraced this protean space mission. That's the end of the section. And I have a figure for you. Where'd it go? There it is. Okay. So this is, let me zoom it in a little bit. This is the image that I believe. Yes, this is the image that's being taken by that one instrument on SOHO, the Large Angle and Spectrometric Coronagraph. So it blocks out the sun, like you can see here. So it allows it to image comets. And so this is SOHO 2000, which is a comet that it discovered. And it's right down here. And it says here, comets travel on high elliptical orbits and some are swallowed by the sun on one of their inward trajectories. This image uses an occulting disk to block out the sun's light, revealing a faint comet to the 2000th to be detected. And it was discovered by an amateur astronomer. Crazy. What are you guys saying? Trying to catch up on chat real quick. Charlie, I like Bossa Nova. You got it. That's exciting. Have I ever seen Claire Saffitz? I have not. Who's Claire Saffitz? is, let me guess. Yeah. I didn't recognize her last name. But yes, I've heard I look like her. She is Claire from Bon Appetit, or used to be from Bon Appetit. She does her own stuff now. I've heard we have the same hair. And are both very pale. Lynn Jersey got her first one. So exciting. Here in India, it's not official yet because some guys are taking trailed vaccines. Oh, that's not good. Ooh. When they're not knowingly taking the other drugs. You were able to receive your second vaccination on Valentine's Day. That's so exciting. You're not. No, it's fun. Stop, Student McLeod. That's awesome that you were able to get it, though. Yay. Hope you're safe and it's working. Yeah, I hope everyone, I know there are a couple side effects here and there, like, you're not going to feel super great. I've heard when you get the second one, that like first day, but I've heard for a lot of people, you get over that first day, maybe a little tired the second day, and then, you're not going to get COVID, or like if you do get it, it's going to be way, way milder and you're not going to die. So that's very exciting. But so hopefully everyone will be able to get it and it will be safe soon. Student McLeod found a picture of my mic. Beautiful. Yeah, that's it. There she is. I guess I could hold it up, but like, there she is. Very exciting. Some argue that GIF is pronounced Jeff, just like the peanut butter. Other argue that it's gift or give because the G stands for graphics. Yeah, it's not an argument that I like to take part in. That's why I always say, if I feel like I never am actually talking about GIFs in real life. It's always in text form, in like in a typed out format. But if I do, I just go off of whatever the other person says, or I say both. Oh, that was Fountain Pen Femme. Thank you for following. Welcome to Teach Astronomy family. I just got thrown off because I realized, can you guys see the alerts but not hear them? Because I normally notice that they happen because the alert sound. But I just got thrown off because I didn't hear the alert sound. And so I think Streamlabs has finally updated it where it won't scream at me, which is very exciting. You can't hear. That's amazing. Okay, I'm going to turn up the volume a little bit on that because it's fun to hear during my streams. But I have been looking for, this is such a tangent. I'm sorry, I will get back to the book in a second. But I have been trying to find a way to turn the audio off on this alert box thing during Professor Impey streams for months because it's very loud and Chris is often very quiet and there was never any way to turn it down. And so now, what a blessing. Also, I missed before Jordan83016. Thank you so much for following. I'm sorry I didn't shout you out when you actually followed. Did I miss anybody else? I don't think so. Okay. I'm glad. Cool. Thank you for streaming educational content. Of course. Thank you for being here, Fountain Pen Femme. That's a fun name. I like it. I like fountain pens. It's a good time. You are waiting for your second dose. It's good. More vaccine chit chat. Has Michael studied anything regarding spacecraft altitude stabilization? I have, or attitude stabilization. I always say altitude. I am not sure. It feels very much more like an engineering topic, so I don't know if that's something that he would have gone into depth on in any of his classes, but we could ask him on Wednesday. It's probably, they've probably talked about it a little bit, they talk about some space missions, but I think that's more of an aerospace kind of thing that would be gone into depth on about like operating gyroscopes and things like that. What's the plant behind me? There she is. It's called a rubber plant. It's not fake. It's actually, that's the name of it. There's like some scientific name, but it's called a rubber plant. I swear to God, it's real. I've been watering it for years. It grew at some point, but it's decided it's done growing now. So it just kind of hangs out. It's very cute, though. I like them. All right. Oh, and more COVID news. Yeah. Merck has a exciting antiviral drug to combat COVID as well, which is really cool. Oh, your topics on spacecraft stabilization, that's really interesting. Yeah, we can definitely we should talk about some of this stuff on Wednesday, because I'd love to ask Michael about it. All right, let's see. We got a good amount of pages left, so we should probably jump back into it, because I see that it's already 11:13. Oh my God. All right. We're just chit-chatting today. We're having a good time. We're hanging out. Getting off topic, you know? I feel bad for the people who watch this afterwards on YouTube, because it's just a bunch of random times where I go on tangents, and they're like, can you just read the book maybe? We'll get there. All right. Aurorae, the sun, and the arts. The aurora borealis and aurora australis occur when electromagnetic particles from the solar wind collide with or excite atoms in the Earth's magnetosphere. We now understand the explicit connection between auroras and magnetic storms, and recently have confirmed the 3-century-old theory that auroras in the northern and southern hemispheres are nearly mirror images, conjugates of each other. Very few people in human history have inhabited the high or low latitudes where these brilliant light displays are usually visible. For thousands of years, the ethereal, vertical curtains of light, draped from 60 to 200 miles above the Earth's polar regions, have inspired wonder, as well as poetic and musical responses. The Vikings first recorded the aurora borealis in AD 1250. About 700 years later, in 1897, Norwegian explorer Fridtjof Nansen wrote of the Northern Lights, quote, "It was an endless phantasmagoria of sparkling color, surpassing anything that one can dream. Sometimes the spectacle reached such a climax that one's breath was taken away. One felt that now something extraordinary must happen. At the very least, the sky must fall." End quote. The 20th century composer Edgard Varese worked with found sound, incorporating sounds with a non-musical origin into his music, and with electronic instruments such as the theremin. He once composed a piece based on having seen the aurora borealis. His wife Louise recalled in her memoir of the composer, quote, "Nature in its most magnificent and terribly impersonal aspects moved him passionately." End quote. Titles for many of his compositions were drawn from astronomy or science. Of the aurora, Louise writes that Varese claimed he, quote, "not only saw, but heard," end quote, the majestic luminescent curtains dancing across the night sky, and later notated, quote, "the sounds that had accompanied the movements of the light," end quote. Electromagnetic waves or natural radio waves can only be detected with a radio receiver. If we take Varese at his word, perhaps he experienced some form of synesthesia, so that in fact he had heard the Northern Lights. In her memoir, Louise Varese speculated that the score of the aurora her husband mentioned was either, oh boy, I think this is French, Les Cycles du Nord, or Meherlicht, that might be German, two of several compositions that were later lost or destroyed. More recently, Terry Riley and the Kronos Quartet's chamber music composition Sun Rings, inspired by the sun's dynamic magnetic field, was written to be performed against a backdrop of IMAX-sized images from the SOHO and the TRACE, the Transition, Region, and Coronal Explorer satellite. Riley's score is accompanied by magnificent sunspots tracking across the face of the sun, as well as finely detailed footage of magnetic field lines breaking through, looping above, and resubmerging into the sun's surface. Such contemporary compositions speak to our deep, primal entanglement with the sun, which is no less important to our lives now than it was in the ancient past. From prehistory to the modern era, humans intuitively understood the sun as integral to their very existence. Paleolithic and Neolithic communities scattered across the globe knew that the sun powerfully shaped their lives. Evidence of their sense of the sun's significance is found at the Mnajara Temple on Malta, at Newgrange in Ireland, at Stonehenge on Salisbury Plain, and at many other megalithic structures. Such monuments speak of an ancient past in which peoples from the disparate times and places were attentive and accurate observers of our star. And I missed before, I just remembered I had a figure to show you. Uh-oh, it's not here. Oh, Jesus. I don't have it. Uh-oh. Hold on. We're gonna look up a picture. The picture in the book is of the Aurora Borealis from space. I'm saying it like that because I have to type the words I'm saying, or else I'm gonna type it wrong. It's about this picture. It's not exactly the same. So if you have the book, it's gonna look a little different. But this is a picture of the Aurora Borealis from space, which is pretty freaking cool. I'm just reading up on your chats while you look at this gorgeous image. A rubber plant is a Ficus elastica. That I don't know if that's true. The aurora is so pretty though. That is a great idea, Parzival, to have he suggested having subtitles. That would be great. I definitely want to look into that. I know that there are ways to do subtitles, and like some streamers have them, and I know they're not always perfect, but it would be very helpful to have. I don't know how to get them yet, but I will look into that because that is a great point, and there are a lot of people, especially during Professor Impey streams, that are not from the United States, and English is not their first language, and it would probably be super helpful if they had a subtitle generator. So I will look into that because I know there are definitely services that will do that. I don't know if they cost money, and if they do, if they're very expensive. But that's also possibly something I could convince Chris that we could get. So I like that. So thank you for that suggestion, and I will look into that. It's a very good idea. Where was I? Here it is. Okay. On the island of Malta, just off the coast of Sicily, are the remains of a complex of stone temples known as Mjandra. I hope I'm saying that right. I'm probably not. Mnajra. We'll go with that. Dating to 550 BC. One of these limestone edifices marks precise alignments with the sun during fall and winter equinoxes. Physicist Giulio Magli describes so many words that I don't know how to say. Physicist Giulio Magli describes Mnajra as a stone calendar marking spring and autumn equinox. Quote, "In the course of the seasons, one can follow the movement of the sun, which rises on the horizon, observing day by day, at which point the light strikes the altar inside the temple." End quote. In walking through Mnajra, sited as it is overlooking the Mediterranean Sea, it's easy to recognize that the location and the megalithic temple were sacred to its ancient architects. Built with cleverness but no metal tools, the effort involved in creating the edifice was prodigious, and a reminder of the investment ancient peoples made in giving homage to the sun. Stonehenge, the remarkable structure ancient Britons built on Salisbury Plain sometime between 3015 and 2400 BC, is so well aligned that, quote, "the general orientation of the axis of the monument looks towards sunrise at the summer solstice in one direction, and towards sunset at the winter solstice in the other." End quote. Caroline Xander observes that, in coming upon Stonehenge, quote, "the great shouldered silhouette is so unmistakably prehistoric that the effect is momentarily of a time warp cracking onto a lost world. End quote. Alexander contends that the architraves atop the monoliths, quote, bound to their uprights by mortise and tendon joints taken straight from carpentry, are an eloquent indication of just how radically new this hybrid monument must have been. It is this newness, this assured awareness that nothing like it has ever existed before, this revelatory quality that is still palpable in its ruined stones. End quote. Though the stone temples at Göbekli Tepe in Turkey are far older and date to approximately 9600 BC, no prehistoric structure like Stonehenge exists anywhere else in the world. Alexander surmises that the Britons who constructed the monument had discovered something hitherto unknown, hit upon some truth, turned a corner. There is no doubt that the purposefully placed stones are fraught with meaning. End quote. Emphasizing the point that the architects deliberately aligned Stonehenge to mark the winter and summer solstices, Magley writes, quote, this is therefore the only information that the builders left us in writing. Granted, it is written in stone, and with stone, and in the language of the sun and of the stones, but it is nevertheless written. End quote. Diodorus of Sicily, a Greek historian from the 1st century BC, supposedly commented on, quote, a lost account set down 3 centuries earlier, which described a magnificent prescient precinct sacred to Apollo and a notable spherical temple on a large island in the far north, opposite what is now France. End quote. Stonehenge, Diodorus suggested, was constructed to pay homage to the sun. As with the relics of any prehistoric culture, multiple interpretations are possible. Archaeologist Mike Parker Pearson of the Stonehenge Riverside Project has recently reinterpreted Stonehenge as a burial monument. He contends that the people who raised the monoliths on the chalk downs apparently gathered each winter solstice to mark the setting sun as the beginning of a new year and to remember their ancestors. Astronomer Edward Krupp has invented the sophisticated and sizable burial chamber in Ireland known as Newgrange or Brunabony. Quote, Newgrange is a megalithic surprise, writes Krupp, who characterizes the structure as emerging from the landscape like a highway tourist attraction. During winter solstice at this stone monument, the first rays of the sun illuminate a room deep in the structure to mark the beginnings of the new year. Dating from about 3700 to 3200 BC, Newgrange was designed so that, quote, 2 weeks either side of the winter solstice, the sun, on rising, shone down the length of the entrance passage and illuminated the central chamber, as it still does. End quote. The beam of sunlight, as it travels deep into the monument, is thinned and sculpted by the megalith's calculated placement. To offer a vivid picture of the massive effort required to construct the edifice, Magley emphasizes that, quote, 5,000 years ago, someone built a monument involving thousands of tons of earth and rock, covered it with quartz like a giant jewelry box, and carefully measured the direction of the sunrise at winter solstice to line up a corridor built with stones as heavy as many elephants together. End quote. Not surprisingly, the legend associated with Newgrange recounts tales of the earliest known Irish gods, the Lords of Light. The Shanquillo complex in Peru predates the Inca by 2,000 years, offering insight into the precursors to sun worship among the Inca and their official sun cult. In 2007, Ivan Gezi, Peru's National Director of Archaeology, and astronomer Clive Ruggles reported discerning the layout of what is considered the oldest solar temple in the Americas. Gezi was first to surmise the purpose of 13 towers on a ridge near Shanquillo, a 4th century BC ceremonial complex in the northern coastal desert region of Peru. Traditionally considered a fortress, Shanquillo is now understood to be a very precise solar observatory built by the people who predated the Inca. Gezi realized that the prominent line of stone towers were markers that indicated the sun's position throughout the months of the calendar year. He contacted Ruggles, and together these researchers, using handheld GPS devices, determined that the location of the towers as projected against the horizon, quote, corresponds very closely to the range of movement of the rising and setting positions of the sun over the year, end quote. In particular, winter and summer solstice alignments are clearly marked by the towers. Ghezzi and Ruggles have shown that the towers and the gaps between them offered a, quote, means to track the progress of the sun up and down the horizon to within an accuracy of 2 or 3 days, end quote. One import of the findings at Tranquillo, writes Ghezzi and Ruggles, is that, quote, sunrise ceremonies at a sanctuary on the island of the sun in Lake Titicaca, surrounding a crag regarded as the origin place of the sun, almost certainly had pre-Incaic roots, end quote. Either the Inca or the peoples who predated them named an island in Lake Titicaca as Isla, I think, right? Isla del Sol, or Island of the Sun, in honor of the god who created the sun, moon, stars, and humankind. It is well known that at the high Andean city of Machu Picchu, constructed in the late 1400s, the Inca kept accurate records marking the winter solstice, the first day of the Inca year. But the Inca may have adopted their attentiveness to the sun from peoples who far predated their civilization. Long before the Neolithic Britons were raising those remarkable trilithons on Salisbury Plain, the Egyptians had already developed writing and record keeping, and were constructing the Great Sphinx at Giza, apparently in recognition of the god Horus, or Hormachet, believed to be a personification of the sun on the horizon. An even earlier instantiation of the sun god Horus was Ra, the patron god of the ancient Egyptian city Heliopolis, located in the Nile Delta. In approximately 2400 BC, Ra was combined with the god of Thebes to become Amun-Ra, the highest deity in the Egyptian pantheon. These are a few of the varied civilizations that recognize the importance of the sun to their survival. In the information age, we're just as dependent on our star as ancient peoples. Maybe even more so. That's the end of that section. Google says rubber plants are Elastica. Okay. I wasn't sure if that was a joke or not. Thought you were. Yeah, you're right. It's Ficus elastica. That's crazy. The rubber fig, or rubber bush, rubber tree, rubber plant, or Indian rubber bush. Yep, it's a great house plant. I could recommend them. I got mine at Home Depot like 4 years ago, and it's still alive, so that's good. Yeah, I'm definitely gonna look into the subtitles thing. That's a great idea. Let's look at Stonehenge. There she is. Thank you for sending me that, Student McLeod. There's Stonehenge, and there's just some guy, I guess. It's pretty funny. That's Stonehenge, and then there were other places mentioned. Well, the Great Sphinx. I'm not going to look up all of them, but you guys have seen this, right? The big cat. To me, it looks like a cat. I know it's not, but it looks like a cat, right? I don't know, just chilling. I think it's a cat. It's supposed to be a cat, right? That's not just me. Does it go boing when I touch it? The plant? No. She just hangs out. It does kind of like, it has like a texture though. Like I could understand why they call it a rubber plant, because it has a texture that almost feels like I don't know. It's very, it doesn't feel like a regular plant. I don't know. It's very weird. But It's a real plant, I swear to God. Oh, Newgrange, thank you. So this one's Newgrange in Ireland. So this is the one where like the sun shines in at like the perfect angle. Soft and thick. Like a succulent? Kind of like a succulent. Yeah, it's got like a succulent texture, but it's a lot thinner than succulent leaves. It's a good plant. Very hard to kill. So that's good for me because I'm not the best with plants. But I've kept that one and 2 others alive for like 3 years, so we're going strong. All right. The Once and Future Sun. Talon Mamat's Lexia to Perplexia is an online fictional hypertext project that interleaves conventional writing with programming code for HTML and JavaScript to explore the ways human culture has been shaped by emerging digital communication technologies. Mehmet writes, quote, "The Earth's own active crust we are, building, building, up and out, antennae, towers to tele." Tele? End quote. Mehmet evokes an interesting concept. Humans have produced an electronic crust, or an information and technology layer, over Earth's surface and extending into orbit. This layer of electronics is comprised of technologies ranging from radio and television relay stations perched on mountaintops to fiber optic lines in homes and businesses, from cell towers dotting the high ground to transoceanic cables in the ocean depths. This data-rich envelope extends from backyard satellite dishes to powerful astronomical radio telescopes lined across the desert in Socorro, New Mexico. I've been there. To billions of dollars in satellite hardware in low Earth orbit. This infrastructure transmits information to cell phones, radios, televisions, computers, global positioning devices, emergency service centers, hospitals, and weather reporting stations, etc. Mehmet writes, quote, "I spread out, pan, send out signals, smoke and otherwise, waiting for echo." End quote. The point is that since the ancient past, humans have extended their communication capabilities over larger and larger distances. They're technologies that today transmit information around the globe at the speed of light. But this diaphanous skin is sensitive to the conditions of the space environment, just as our skin is sensitive to the sun. Never before have we been so dependent upon an understanding of the inner workings of the sun and its impact on the electronics that sustain our information-based culture. As we continue to expand and rely on this electronic information layer encasing the Earth, we're increasingly impacted by the sun's powerful magnetic reach. Evolutionarily, we've adapted to living with our star. As John Freeman points out, humans, like other mammals, insects, and plants, have evolved, quote, "sense organs that can make use of the sun's outward flood of electromagnetic radiation. It's not an accident that our eyes are sensitive to the same portion of the electromagnetic spectrum where solar radiation is most intense." End quote. Similarly, our skin is well adapted to sunlight in a number of ways, one being that in about 15 minutes of exposure, our skin absorbs the daily recommended amount of vitamin D. Our lives are intimately bound up with the sun, and not just because of our need for its light and warmth. The iron in our blood was forged inside massive stars over 4.5 billion years ago, and then surfed the blast waves of supernovae into interstellar space. Stars like the sun spewed heavier elements into space that eventually coalesced into our sun and solar system. Harlow Shapley popularized this concept in the early 1900s by claiming that we are made of star stuff. The human body, as all life on Earth, is comprised of carbon, calcium, oxygen, and other heavy elements forged in the cores of stars that exploded long before our sun was born. Given how much more there is to it than meets the eye, it's fitting that one of NASA's initial Braille books for the blind focused on the sun. The Solar Dynamics Observatory, launched in early 2010, is carrying on Soho's work with even greater accuracy in examining the sun's interior and interpreting the sound waves traveling inside and across its surface. Part of NASA's Living with the Star program, SDO is tracking magnetic fields within the sun in hopes of discovering the mechanism that drives the sun's 11-year cycle. SDO is sending data to Earth at a rate 1,000 times faster than SOHO, equivalent to downloading 300,000 songs, a day. The satellite is 50% heavier than SOHO and views the sun in high definition, or nearly IMAX quality, taking a picture in 8 different colors every 10 seconds. It's serving as a first alert against magnetic storms sweeping over our fragile home in space. We've learned from SOHO and other missions that the rock-steady light from the sun, varying by less than 1% from year to year or decade to decade, is not the whole story. In invisible forms of radiation, the sun is epic and Byzantine by its behavior, and scientists have not fully understood this apparently simple, middle-aged, and middleweight star. Scattered through the Milky Way galaxy, there are an estimated 100 million habitable Earth-like worlds orbiting sun-like stars, and each will have its own complex relationship with its parent star. Our sun and the space weather it produces will determine the future of our species, as well as that of all life on Earth, even the planet itself. Having sustained our world for billions of years, the sun is still a devoted protector and guardian. It reaches out across 100 million miles to cradle, caress, stroke, and occasionally scold us. And that's the end of the chapter. I did not think we were getting to the end that fast, and then I turned the page and it was the end of the chapter, but that's it. That's Soho. That was great. I really enjoyed that. I did not, this again was like last chapter about Stardust. I did not know a lot about that mission before we read it, and it was very interesting. The Very Large Array is near Socorro, New Mexico. It's 50 miles out from Socorro. Professor EXP is rating with a party of 6. Hello! Thank you so much, Professor EXP. Welcome. Thank you so much. Welcome fellow nerds, I'm going to assume. Professor EXP sounds very in a similar vein to us. How you doing? I just realized my alert box is still turned off. Whoops. Sociology. Oh, that's so cool. Welcome. Well, we are as the name suggests, we're an astronomy group. We actually just finished reading a chapter in this book called Dreams of Other Worlds about SOHO, which is the solar observatory hanging out up in space. Actually, I was meaning to look up because, as I've said before while reading this book, this book came out in 20... Oh, you were doing a VR stream. That's cool. 2013. Yeah, this book is all about different unmanned space exploration or unmanned space missions. And we read about SOHO today. But it came out in 2013, which is why I wanted to look up what the status of SOHO is now. So I'm going to go back to that SOHO NASA website that Student McLeod sent to me before. Here we go. Oh, this is a different one, actually. Oh, why is it so zoomed in? Oh, my. Oh, my. Okay. So I found a second website, apparently. This is the page in their mission, like, gallery. Gotcha. So let's see. Is it still going? So originally it was meant to operate until 1998, like it said, but it got multiple extensions, and the last extension was till 2016. And I'm trying to figure out if that was also extended. It doesn't actually say here. Let me hold on. We're going to check the Wikipedia. Did anyone else? Okay. I know we have a large variation of age ranges on this stream, but I was wondering, because I was talking about this the other day with some of my friends, do you guys remember back in like maybe, I mean, it was really only like 10 years ago. I was in high school, but like Wikipedia, I remember being told in high school and like middle school, like never, ever, ever use Wikipedia as a source for anything. It's always going to be incorrect. Like anyone can edit it, so it's going to be wrong. And now I go to Wikipedia for everything. Like you still shouldn't use it as like a source for like if you're writing an academic paper or something, but like it's a pretty good website, you know? It's pretty good. And I don't know when that switch happened, but I just thought that was pretty funny. But let's see. So, it looks like... Oh, it's still going. Apparently, it's still going. It looks like here, because it says the mission duration was 2 years planned. So that like 1998 end date that it planned, but NASA and ESA always design their stuff to last way longer than that. So... currently, it has elapsed 25 years, 3 months, and 26 days, and it's still going strong, it sounds like, which is pretty cool. I just hit the mic. Sorry about that. Oh, there you go. Lynn Jersey said they found that it's been extended until the end of 2020 with likely extension until 2022. Nice. Yeah, use the references used in Wikipedia, but don't cite the Wikipedia, definitely. Because there are so many, like, people... I think it's just like there was this collective effort of like we need reliable and easy to access like educational resources online, and people just like hopped on that bandwagon hard like 10 years ago, and just like, I mean, even this article here, it's not even that long, the Soho article, but it's got 20 something, like 26 different references, you know, which is pretty cool. Oh yeah, this is the other website for Soho if you guys want to check that out as well. So this is the full Soho website. The other one was just like their mission page. But yeah, it's pretty cool. You can see some pictures from their galleries, sunspots and solar activity, stuff like that. Cool stuff. What else did you say? Evil Ozzy? Oh, thank you so much for the compliment. I'm glad you enjoyed it. Oh, the map of NRAO. It's not, there it is. Okay. Yeah, so the book mentioned the Very Large Array, which I have been to and is really, really cool. And I believe they typically do like public days. So if you're like in that area, you can just like go, and they have kind of tourist areas where you can learn about some stuff, and it's really cool. It's really, really cool to see if you're into radio astronomy or into the movie Contacts, which I am both. And so we went out there for an active galactic project a couple years ago now. Oh man, it's been a minute. But it's about 50 miles outside of Socorro in the middle of scenic nowhere. And yeah, you can see on the map here. That's Socorro right here, which is a very small town in the middle of New Mexico in the southwest United States. And this is about 50 miles away, VLA. I wonder if with satellite we can see the dishes. Okay. Yeah, you can. Okay. So, this is like this is VLA Road, apparently. These are some of the facilities and buildings. They have like a research building, and then they have some facilities for construction and stuff like that. This is probably the tourist building, I think. They've got some nice tours and stuff like that. It's really cool. A really nice place. Really great people. And then you can see the dishes. I don't know what configuration this is in, because they change, but you can see the dishes here, and these are railways, so it's all on train tracks, so they can move the dishes, and they extend out to pretty far. This is the farthest one on this arm, so it's pretty wide. It's like that, which is really cool. So yeah. What else did you guys send me? Oh, the Soho other site, yes. Does Ellie Arroway still work there? I wish she did. Actually, the guy who does work there, who helped us with everything, getting permission to go there and filming and stuff like that, and finding people to talk to, such a nice guy. Dave Finley has been their like PR director. I don't know if that's his official title, but like public. He does the public relations stuff, and has been doing it for decades now. And he was there when they filmed Contact, and he said that he got to he was not security, but he was kind of the person watching while everything was going on to make sure that nobody touched anything they weren't supposed to touch and stuff. But he said it was a pretty cool set to be on, and got to meet I'm blanking on her name, but the actress who plays Ellie Arroway. But yeah, I think that's about it. I feel bad because we just got raided with some new people, and I have to wrap up the stream now. But hopefully those new people like Jodie Foster. Thank you, Jodie Foster. But hopefully, Professor EXP, we could see you and some of your other viewers next time. You can give us a follow so you know when we're going to go live again. For new people, our regular schedule is Monday, Wednesday, Friday. On Mondays, we do this book stream thing where I read a chapter of a book, and we hang out and have a good time. On Wednesdays, we usually do astronomy news chat. So me and my friend Michael talk about different stuff in astronomy news, or sometimes we have special guests. And Fridays, we do amateur astronomy, where we talk about amateur astronomy stuff. So going out, doing stargazing, buying telescopes, stuff like that. Have a good time. And Professor Impey also does his Q&As every other week. He is a professor at the University of Arizona, and is very knowledgeable about like everything that you would ever want to know in astronomy and astrophysics. So those we do every other week. So yeah, feel free to follow if that sounds like something you'd be interested in. Also, we are Twitch affiliates. If you want to subscribe, that would be great. It helps out the channel a lot. And before we go, actually, I'm going to plug a personal thing. I have, I've mentioned it a couple times. I have a podcast. So if you like listening to my voice here, talk about books, or read books, not talk about astronomy, you might like listening to my voice playing a character on a podcast called Cryptid Cape. It is a podcast about a young woman who moves to a new town, looking for a new start, and finds herself living in a town full of cryptids. It is a fictional little story. We have two seasons already. It's really fun. I have a whole host of characters, and they are great. Yes, it's written by me, edited, produced, all that jazz. And then I have a bunch of wonderful voice actors. And we are currently doing a little Indiegogo campaign. It ends in a couple days. And we're going to be doing a live show online as part of the Indiegogo campaign. So if you're interested, I'll send you the link here. How do you reach Cryptid Cape? Well, I will tell you. I'm gonna... I think that's the... No, not Cryptid Caper. That's not my podcast. Give me the page. We just moved to a different platform, so now it's harder for me to find my link. Here it is. So we're hosted on a podcast platform called Spreaker, so that'll bring you right there. But we're also on literally every other podcast platform. So if you like your Apple Podcast, you like your Google Play, Stitcher, Spotify, Amazon Podcast, I believe is what it's called. Podcast Addict, GeoSavan, Deezer, Castbox. I'm just reading the ones that are listed on my website now. It is on Spotify. Yes, Cryptid Cape is on Spotify. Yeah, it's a fun little show. You have a lot of really great people on it, and I think it's a good story. And here's the Indiegogo campaign if you want to look at it, if you're interested. I just wanted to plug that because it's one of the other big things I do. I have many a job, I guess, outside of Teach Astronomy, and thought it would be cool if you guys knew about it. So I think I'm going to wrap it up there, and thank you all so much for joining me today. I hope you enjoyed learning about SOHO. I sure did. And I will see you guys next week. Next week's chapter is about Hipparcos, mapping the Milky Way. So look forward to that. And if I don't see you on Wednesday or Friday, I'll see you then. So have a good day, everybody. Bye.